All right, we are going to be starting with chapter 6. Chapter 6 stuff is basically exponents and radicals. It's simplifying exponents and simplifying radicals. And that's what we're going to be doing today. A lot of the stuff you already learned in Algebra 1. A lot of today's lesson you've already learned in Algebra 1. Okay? However, it's not easy. This lesson is not easy. So please do not say, oh, we did this before, it's really super easy. No, it's a very, very difficult lesson. So you need to make sure that you are paying attention and that you are with me the entire period. Now, for every real number x and exponents a and b, where a and b cannot be 0, then the following is true. Okay? X to the a times x to the b. I have one base with two different exponents. What you're going to do is you're going to add those exponents together. Green poster over here on the board in front of my desk here. See this green poster? It shows you x squared times x cubed equals x to the fifth. Okay? It'll stay up here all year long. Utilize it. This green poster here and the red poster is what you're going to be utilizing today. Okay? These two end posters. Now, the second one says that if they're attached by multiplication up here, and I added the exponents in number 1, these two are going to be attached by division, so the opposite of addition is subtracting. So that's why you're subtracting for number 2. Yes? Okay, number 3. I have one base raised to two different powers. So you're going to simply multiply those exponents. Again, this is all going to be on the green poster. Okay, this is the green poster up there. So make sure that you remember it's the green poster. Okay? Then x to the 0 power is always in forever 1. Guys, look, if I have 13 x to the negative 2 y z all raised to the 0 power, you know what happens? The whole entire thing turns into a 1. Okay? So it doesn't matter if you have the entire alphabet in there. If the entire alphabet is raised to the power of 0, then the outcome is 1. Okay, this has, if I have a negative exponent and it's in the top, to make that negative exponent become positive, you move it to the bottom. If it was in the bottom, and you want to move it to the top, to make it positive. Okay? Now, over here, we're going to be talking the red poster. So these three are the red poster. Whereas these first three were the green poster. Do you all understand that? Yes or no? Okay, super important that your brain gets that over there. They will be there all year long. So the red poster over here is if I have x to the negative n, that makes it 1 over x to the n. 1 over x to the negative n makes it x to the n, and x to the 0 is always 1. Okay, it's there all year long. Now, number 7 says if I have two different bases raised to one exponent, simply distribute the exponent into each of them. Same exact thing here. Simply distribute and multiply those into it, and you'll be fine. Okay? The second one here goes ahead and it gives you some examples. I give you some actual physical examples. I strongly suggest as you're doing your homework, you look at those examples. We've already gone over a lot of these, and we're going to go over them today in class as well. So let's go straight to the example. Okay? The example we're going to be talking about, I refer to this as the piggy bank problem. The piggy bank problem is basically where when you dump out your piggy bank, what's the very first thing you do with all the coins? What? Separate them, sort them, right? You're sorting them according to nickels, dimes, quarters, pennies, right? Okay? You're going to make piles. Well, that's exactly what you're going to do here. You're going to look to see, do I have any exponents outside of the parentheses? No. All of these are attached by multiplication. Would you agree? So multiplication can be torn apart and rearranged to suit your mental needs. Does that make sense? So what you're going to do is you're going to tear this apart and make this 3 times negative 7, x to the 4th times x cubed, y to the 5th times y. So I rearranged, and now I'm going to put on any phantom exponents. What's a phantom mean? Phantom means what? Phantom. If you have phantom pain, it's not really pain that you can see. It's not there, right? It's something that's there, but you can't see it. Okay? So we're missing 3 times -7. So you're looking for anything that has any missing exponents. So do you have any missing exponents up here? The y has a phantom 1, and you're going to put that 1 there, okay, so that you don't ignore it. So now what we have are 3 individual problems. Do you see that? I have 3 times -7 as one problem, x to the 4th times x cubed is another problem, and then the last one is y to the 5th times y to the 1st. Would you agree? Simply calculate each problem. So 3 times -7 is going to be -21. What do you do with exponents right here with the 4 and the 3? We add them because they're attached by multiplication, so you're going to add those to give you x to the 7th. And then over here on the y's, what are you going to do? Add them again to give you y to the 6th. Then this problem is done. Do we understand that? This is an Algebra 1 problem, but it's going to get tricky because you're going to have negative exponents, okay? Now, I'm going to do this problem 2 ways. You only have room to do it 1 way, so you might want to draw a line down the middle of your problem so that you can see that we're going to do this 2 separate ways. Now, what you have here is a problem that has division in it. Would you agree? It has a fraction bar. So what that means is you have a problem up top you need to simplify, and then you're going to have a problem in the bottom that you need to simplify. Do you understand? Yes? What we're going to do is we're going to simplify the top first by doing exactly the same steps as we did before. Do I have any exponents on the outside of the parentheses in the yellow on the numerator? Exponents on the outside of the parentheses. What are my exponents on the outside of the parentheses? That's x squared. That 2 goes to the x squared. It doesn't go to every single term in the parentheses. What I'm looking for is something that is going to be up here. Is there anything up there? Is there any number up there? No, there's nothing there. It's understood to be a 1. So if I distribute a 1 into everything, it doesn't change anything, does it? Do we all get that? Yes? Okay. So that means that all of these are attached by multiplication. So I have a piggy bank problem that I can simply rearrange some things, yes? So I have -2x times x squared times y cubed. Would you agree? Yes or no? Okay, look at the bottom. Do I have any powers that are exponents on the outside? Yes, I do. The power that I'm looking at is going to be this lovely little 3 right there. Yes? What happens with that power of 3? It distributes to where? To every single thing inside the parenthesis. So I'm going to put a power of 1 on the number 3. Do you see that? So the coefficient 3 has a missing phantom exponent. That variable and that number 3 have to both get, I'm going to erase that there, have to both get this 3, meaning you are simply going to distribute to both of those. Do we see that? So this is going to be 3 cubed times x to the 12 times y to the 9th. Do we see that? Now let's look at the top. What do I do with my x's? Add the exponents. So I'm going to put on my missing phantom exponent, which is x to the 1st. And what is that going to give me? X cubed, y cubed. So my top is simplified completely. Now my bottom. What is 3 cubed? What does 3 cubed mean? 3 times 3 times 3, which is 3 times 3 is 9, times 3 is 27. Why did I write 73? Okay, 27. X to the 12th, y to the 9th. Okay, now I need your brain to visualize this. What does it mean to be x cubed? What is x cubed? X times x times x is x cubed, right? What's x to the 12th? 12 times. There's 12 x's down there, yes? Now I want you to visualize this a minute. The 2 over negative 27, I can't do anything with that, can I? Right? However, if I have 3 x's up top and I have 12 x's on the bottom, how many x's do I have where when things cancel out? I have 9 x's that remain uncanceled in the bottom. Do we all understand that, yes or no? Make sense? Because there were 3 up top and there are 9 on the bottom, or 12 on the bottom, and if 3 up top cancel out 3 in the bottom, what remains is 9 left in the bottom. And I'm going to show you another way here in a second. Now, if I have 3 y's on top and 9 y's on the bottom, how many y's are left after things cancel out and where? There are 6 y's left on the bottom to give you y to the 6. This is your answer. Now, at this point, many of you would have been like, okay, I don't like that because I can't visualize that in my head. I want to use the rules. Then use the rules. If you use the rules, you have negative 2 over 27, and then you have this problem right here, which means those are attached by division, which means you subtract the exponents. When you subtract the exponents, what that means is they automatically are in the numerator. Does that make sense? Yes? So you're going to have 3 take away 12, which is going to be negative 9 and negative 6. But those are where? In the top. I need them to be positive, so where am I going to put them? In the bottom, to give you negative 2 over 27, x to the 9th, y to the 6th. Exact same answer with a different thought process. Okay? You will have to use the negative concept, the negative exponent concept at some point. All right? Do we understand how I did that? If your brain can do this without doing the negative exponents, then do it. If it makes sense to you. Okay? All right. Next. This is the quantity a plus b raised to the negative 3. That a is attached to the b by what operation? Addition. Here's the thing, folks. I need your brain to think like this. The A is the head, the B is the body. They cannot be separated, because if you do, then you're not going to walk around for very long, correct? So the A plus B is an entity that cannot be separated. So what I have to do is keep that together, and I'm going to put this over 1. Why am I putting it over 1? Because I have a negative exponent, and can I have negative exponents? No. So how do I turn this into a positive exponent problem? I take the whole expression and I bring it down to the bottom, and I make that exponent, instead of negative, turn into a positive. Now, tonight's homework is going to be the exponent review worksheet that I'm going to pass out to you now. Okay, so let's go ahead and start tonight's homework so that you know what you're doing. I'm going to start with number 2. Are you ready? Okay, so first things first, put on any missing exponents anywhere. Do I have any exponents on the outside of the parentheses that need to be distributed in? No, so this is a piggy bank problem, isn't it? Where you can simply rearrange things. So if I rearrange things, this is going to be 2 times 3, x to the 4th times x to the negative 1, y to the 7th times y to the 5th. Does everybody understand what I just did, yes or no? Questions? Two times 3 is? What do I do with the exponents on my x's? Add them. So what is $4 plus owing $1? 3. Do we all understand that? So that's x cubed. What about 7 and 5? What do I do with those? To give you? 12. 12 times x to the 5th. 12 times x to the negative 1. 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 12 times x to the negative Done. There are no negative exponents. It's done just the way it is. Do we understand? Okay, next, number 4. Now, what I want you to do before you do that is I want you to put on any missing exponents anywhere within the parentheses. So, does 3 have an exponent on it currently? You need to make it have one by putting a 1 there. Does the 4 have an exponent on it? Make it have one by putting a 1 on it. Does D have an exponent? Yes. Does E have an exponent? Do we all understand what you have to do first? Now, what am I going to do with the -2 exponent on the outside? You are going to distribute it into every single power on the inside. And what operation are you doing? Multiplication. So this is going to give you 3 to the first times -2 gives you what? 3 to the -2 over 4 to the -2 times d to the -6 times e to the 10th. Catch it, catch it. Okay, now what? What's up? Okay, you can. What your brain needs to understand is you can extend this and understand that when you do that, it automatically goes in the numerator. Do we understand that? So when you have a variable in the middle, that variable in the middle actually means that it is going to be in the numerator. Do we get that? Yes or no? Okay, so now I need to have some positive exponents. How do I get positive exponents? Well, 3 to the -2 is currently negative. What position? In what position? The numerator. So to make it positive, where's it going to go? It's going to go to the bottom to make that 3 squared. 4 to the -2 is negative in the bottom. So to make it positive, it's going to go to the top. D to the -6 is currently in which position? The numerator. So where's it going to go? Denominator. And e to the 10th is positive in which position? It stays in the numerator. So have you ever heard that song, Should I Stay or Should I Go Now? Okay, that's what you're doing. Should it stay where it's currently at because it's positive, or should it change or go in the opposite position because it's negative? Do we all understand that? Okay, so what is 4 squared? What is 3 squared? D to the 6th. This is done. Do we understand that? Come in. 3 does not go into 16. But if it could be reduced, you'd reduce. Nope. The reason why is because variables have to have the same variable on the top and the bottom to reduce. E to the 10th and D to the 5th are not the same variable, so you can't. That's like having dogs and elephants. It's not possible. Elephants can cancel out with elephants. Dogs can cancel out with dogs. You with me? Okay. Keep going. Number 6. Okay, what do you think? Distribute. He says, I'm going to go ahead and distribute because guess what? I have a power on the outside, and that has to go to the inside power by doing what operation? So this is going to give you u to the -24 times, go to the next one, u to the +24. Now, what do you do with those two exponents? You add them. So what's -24 plus +24? It's u to the 0, and what's anything to the 0 power? Always and forever 1. Now, is this the only way to do that? No, your brain could have been like, hey, that has a negative exponent. So if your brain saw this, and you're like, hey, that's negative, I want to put that down to the bottom. If your brain saw this, you're still going to get 1, aren't you? you're still going to get 1. So it's a matter of how does your brain attack this problem, okay? Whenever I look at your papers, not everybody's paper is going to look the same, okay? Keep going. Number 12. Number 12. Okay, what do you notice? Okay, it's a fraction, right? But let's look at the numerator. Is there anything that needs to be multiplied or added or anything at the top? So the numerator problem is completely done at this point. Would you agree? Except for there's a negative exponent that we don't like, yes? So if your brain says, hey, can I get rid of that negative exponent? You can if you want to, okay? Now let's look at the bottom. What's happening to the bottom? I have to distribute, but before I distribute, what do I always have to put on? Your phantom exponent. So I need to put a 1 on the 5 and a 1 on the y. Because is there an exponent on the outside? Right. Does that make sense? Okay, so now I'm going to go ahead and I'm going to drop down the numerator because I'm not going to change it at this point. There's nothing that I can do to it. But the denominator, I am going to change it. What is that going to turn into? 5 to the negative 3, x to the negative 6, y to the negative 3. Do we all see that? Yes or no? Okay, now from here, you would go ahead and say, how many different problems do you have? I have the number problem, I have the x problem, and I have the y problem. Do you see that? Okay, so if I'm looking at my numerical problem, should the 25 stay where it's at or should it go? It stays where it's at because it's 25 to the first power, correct? Should the 5 to the negative 3 stay in the denominator or go? It goes to the top and becomes 5 cubed. Do we all understand that? Yes? Yeah. Do we get that? Yeah. So what is 5 times 5? Times 5, 5 quarters in your hand gives you? So you're going to have 25 times 125. Can somebody do the multiplication for me of 25 times 125? So this is going to be 3,125, and that is the numerical problem. Did you see how we worked that all the way down? Okay, now let's go ahead and do the x's. When you're doing the x's, how are my x's attached? By division, so I'm going to subtract my exponents. So this is going to be negative 5 minus negative 6. What's a double negative create? So this is actually plus 6, right? So what is negative 5 plus 6? So this is going to be x to the first. Yes? Now go to the next one. Y to the third. I don't need you till 8.
I know. I was just going to see if there's any special I need to know.
I'll let you know. I'm recording right now. Thank you, though. Y cubed divided by y to the negative 3. What do I do? How are these attached? So what am I going to do? I have 3 minus negative 3. A double negative creates a positive to give you y to the 6. So your answer is 3,125 x to the first, y to the 6. Let's do another one, number 13. Okay, what do you think? Phantom exponents. Why do you want to put phantom exponents on? Because there's powers on the outside. So this 4 has to have an exponent of 1. The y has to have an exponent of 1. What else? 3 and the other y. Do we all understand that? Yes? So what is 4 over y raised to the third power? What's that going to be? 4 to the third over y to the third times, what's the second one going to be? 3 to the fourth over y to the fourth. So what is 4 times 4 times 4? Well, what's 4 times 4? Times 4 is 3 times 3 is? 3 times 3 is? 9 times 9 is? 81. Over y to the 4th. Now, what is 64 times 81? And how many total y's do you have on the bottom? Y cubed is y times y times y, so I have 3 there. And then y to the 4th is y times y times y times y, so how many y's do I have? 7. Add those up. Done. It's harder. Would you agree? It is harder. Do you remember doing this in Algebra 1? You did it. You just probably weren't very effective at it, which is why we're reviewing it hardcore. Okay? Now, you guys have the rest of this worksheet to complete for homework tonight. Tomorrow, I'll make sure that you have the answers. If something happens, I'm not here, you'll have a video. Okay?